Arc fault circuit interrupters, or AFCIs, are designed to protect against fires caused by electrical arcing. An arc fault is an unintended electrical discharge between two or more conductors. Traditional circuit breakers protect against overloads and short circuits, but they do not detect arcing faults. AFCIs, on the other hand, are specifically designed to detect these dangerous conditions. There are two main types of arcing faults: parallel arcs, also known as line-to-ground or line-to-neutral arcs, and series arcs. Parallel arcs occur when there is a fault between a hot wire and a neutral or ground wire. These types of arcs typically draw a large amount of current and are easily detected by AFCIs. Series arcs occur when there is a break or loose connection in a single conductor. These arcs are more difficult to detect because they may not draw a significant amount of current. The claim that an AFCI can detect series arcing is a complex issue. Typically, AFCIs are more adept at detecting parallel arcing faults, which involve higher current flow and distinct electrical signatures. Series arcing, on the other hand, presents a greater challenge due to its lower current levels and less pronounced signature. The detection of series arcing relies on the AFCI's ability to analyze the waveform of the current and voltage. AFCIs use sophisticated algorithms to identify patterns that are characteristic of arcing faults. These patterns can include high-frequency noise, irregular current fluctuations, and voltage drops. If an AFCI detects these patterns, it will trip the circuit breaker, interrupting the flow of electricity and preventing a fire. Firstly, let's consider how parallel arcing is detected. Parallel arcing, which occurs between a hot wire and a neutral or ground wire, typically involves a significant surge in current. This abrupt change in current is easily detected by the AFCI's internal sensors. The AFCI is designed to trip almost instantaneously when it recognizes this type of fault, cutting off the power supply to prevent a fire. Secondly, the detection of series arcing is considerably more complex. Series arcing happens within a single conductor, often due to a loose connection or damaged wire. Because the current flow may not dramatically increase, series arcs are harder to identify. Advanced AFCIs use sophisticated waveform analysis to detect subtle irregularities in the current and voltage signals that are indicative of series arcing. These irregularities may include high-frequency noise or distortions in the sine wave. The effectiveness of series arc detection is a topic of ongoing debate and research. Some manufacturers claim that their AFCIs can reliably detect series arcs, while others are more cautious in their claims. The ability of an AFCI to detect series arcing depends on several factors, including the design of the AFCI, the type of load in the circuit, and the characteristics of the arc itself. Series arcing is often considered less likely to cause fires compared to parallel arcing because the heat generated by the arc is typically dissipated along the length of the conductor. However, in certain conditions, such as when the conductor is surrounded by flammable materials, series arcing can still pose a fire hazard. Design and construction of AFCIs have evolved significantly over the years. Early AFCIs were relatively simple devices that relied on basic current sensing techniques. Modern AFCIs incorporate advanced microprocessors and sophisticated algorithms to improve their accuracy and reliability. These advanced AFCIs are better able to distinguish between normal circuit activity and arcing faults, reducing the risk of nuisance tripping. Changes in AFCI design can sometimes lead to installation challenges. One common issue is the increased size of newer AFCIs, which can make them more difficult to fit into crowded electrical panels. This can be particularly problematic in older homes where the electrical panels were not designed to accommodate larger breakers. In such cases, installers may need to get creative with their wiring techniques to ensure that the AFCIs fit properly and that the panel cover can be securely closed. Another challenge associated with AFCI installation is the need to properly terminate the neutral and ground wires. AFCIs are sensitive to wiring errors, and improper grounding or neutral connections can cause them to trip unnecessarily. It is important to follow the manufacturer's instructions carefully when installing AFCIs and to ensure that all wiring connections are tight and secure. The National Electrical Code, or NEC, provides detailed requirements for the installation of AFCIs. The NEC requires AFCIs to be installed in all branch circuits that supply receptacles in dwelling units, with some exceptions. The purpose of these requirements is to provide a greater level of fire safety for homeowners. The NEC is updated every 3 years to reflect changes in technology and best practices. Electrical inspectors play a critical role in ensuring that AFCIs are installed correctly and that they are functioning properly. Electrical inspectors are responsible for reviewing electrical plans, inspecting electrical installations, and enforcing the requirements of the NEC. If an electrical inspector finds a violation of the NEC, they can require the homeowner or contractor to correct the problem before the electrical system is energized. When dealing with electrical equipment, safety is paramount. Working with electricity can be dangerous, and it is important to take precautions to avoid electric shock and other hazards. Always turn off the power to a circuit before working on it, and use insulated tools to prevent accidental contact with live wires. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. The claims made by manufacturers regarding the capabilities of their AFCIs should be carefully evaluated. It is important to review the manufacturer's specifications and technical documentation to understand the limitations of the device. Independent testing and certification can provide additional assurance of the AFCI's performance. Organizations such as Underwriters Laboratories, or and the Canadian Standards Association, or CSA, test and certify electrical products to ensure that they meet safety standards. The detection of series arcing is a complex and evolving field. While some AFCIs may be capable of detecting series arcs under certain conditions, it is important to understand the limitations of these devices. Proper installation and maintenance are essential to ensure that AFCIs function properly and provide the intended level of fire protection. Ongoing research and development are leading to improved AFCI technology. Future AFCIs may incorporate advanced sensing techniques and signal processing algorithms to enhance their ability to detect both parallel and series arcing faults. These advancements will contribute to a safer electrical environment for homes and businesses. When selecting AFCIs, it is important to consider the specific requirements of the application. Factors to consider include the type of load on the circuit, the age of the wiring, and the presence of any known electrical hazards. Consulting with a qualified electrician can help you choose the right AFCI for your needs. Regular testing of AFCIs is recommended to ensure that they are functioning properly. AFCIs can be tested using a test button that is located on the device. Pressing the test button should cause the AFCI to trip, indicating that it is working correctly. If the AFCI does not trip when the test button is pressed, it should be replaced. The cost of AFCIs can vary depending on the manufacturer, the type of AFCI, and the features that are included. While AFCIs may be more expensive than traditional circuit breakers, the added protection that they provide is well worth the investment. AFCIs can help to prevent fires, protect lives, and reduce property damage. The use of AFCIs is just one component of a comprehensive electrical safety strategy. Other important measures include proper wiring practices, regular electrical inspections, and the use of surge protectors. By taking a proactive approach to electrical safety, you can minimize the risk of electrical fires and other hazards. The design changes in AFCIs, particularly the increased length, have raised concerns among electricians and homeowners. The longer form factor can make it challenging to install the breakers in existing electrical panels, especially those that are already crowded with wiring. In some cases, the breakers may interfere with the panel's neutral and ground bars, requiring installers to bend the wires sharply or cut them shorter than ideal. This can compromise the integrity of the connections and potentially create safety hazards. Manufacturers are aware of these challenges and are working to address them in future designs. Some manufacturers are exploring alternative form factors that are more compact and easier to install. Others are developing new wiring techniques that can help to mitigate the space constraints in electrical panels. The electrical industry is constantly evolving, with new technologies and standards emerging all the time. Staying informed about these developments is essential for electricians, homeowners, and anyone else who is involved in the design, installation, or maintenance of electrical systems. Trade publications, industry conferences, and online resources can provide valuable information about the latest trends and best practices in electrical safety. When dealing with electrical issues, it is always best to err on the side of caution. If you are unsure about something, consult with a qualified electrician. Attempting to perform electrical work without the proper knowledge and training can be dangerous and can lead to serious injury or even death. Electrical safety is a shared responsibility. By working together, electricians, homeowners, manufacturers, and regulators can help to create a safer electrical environment for everyone. It is essential to address concerns about the detection of series arcing and the installation challenges posed by newer AFCI designs. These issues require ongoing attention and collaboration within the electrical industry to ensure the safety and reliability of electrical systems. The continuous advancements in AFCI technology promise enhanced protection against electrical fires, but it is important to stay informed and adapt to the evolving landscape of electrical safety standards and practices. Firstly, one must keep up to date with NEC requirements. Secondly, one should refer to manufacturer specifications for the latest models of AFCIs. Thirdly, consult with qualified electricians regarding suitable solutions for difficult installations.